Hello, my name is Toby,
I'm Geir.
and so we are running here this multi-axial test, which is part of a wind turbine blade. And basically, what we have here is we have a horizontal actuator that induces shear load into the web, the vertical part of this three-dimensional T-joint. And then we have two vertical actuators that induce cross-sectional deformations into this test piece. And so the load profile that we are analyzing at the moment is the following. So what we do first is we're loading actuator 2, which is one of the vertical actuators, up to a load to 10 kilonewtons. Then we load the horizontal actuator to 5 kilonewtons, and then we are cycling the vertical actuator. So it's a combined complex stress state in that. And whilst we are running this test, we are taking some images. Here, what are we imaging?
So we have a number of cameras around the test specimen. So we've got white light cameras to do digital image correlation. What we get from those cameras is a displacement field across the imaging field of view that we're looking at. The displacement field can then be differentiated to give us strain field. So we're getting both displacement and strain from our white light cameras. We've also got two thermal imaging cameras, and what we can do with that is a technique called thermoelastic stress analysis. So what we're doing there is we're exploiting the thermoelastic effect, which is when you apply a stress change to a material, you also see a temperature change. So we can infer the stress distribution by looking at the temperature distribution across the field of view with our thermal cameras. And we actually have two thermal cameras on this particular specimen, two different types, both different in size, cost, and performance, and we're making comparisons between the two cameras and trying to use some of the cheaper technology and achieve similar performance to the expensive cameras that we have. So here we have the white light cameras, so we have two cameras. What that allows us to do is actually measure outer plane displacements too, so this is depth perception, similar to what we have with our eyes. And the kinds of data that we get out from that, I think Toby's going to show us quickly now.
Yeah, if I can find it. This one is okay. So this is the displacement field, out of plane displacement at zero load, and then this is loaded.
Obviously exaggerated in this particular plot, but yeah. So we're measuring here out of plane displacements with our two cameras here that are marked on this image. Then on the next camera here, we've got thermal imaging. So from that you can see the temperature distribution across the field of view. The variations you can see in this particular live image now is just because the emissivity is slightly different across the field of view. And then we have this photon detector image here. So this is a very expensive camera. It's very capable in terms of it can record very, very fast, and it's very sensitive. And we're making comparisons between those two cameras.